What's up, guys? Let's jump into chapter 1.3. Alright, 1.3 is linear functions and really just kind of builds on what we learned in chapter 1.2. So, a linear function is a function that can be written in the form f of x equals ax plus b, where a and b are constants. So, this first part asks, it says, is y equal 5 a linear function? Indeed it is. So, if we want to add notes here, let's use just a traditional black here. So if I wanted to write this in this traditional function form, essentially it is a linear function because your a here is just 0. 0 times x plus 5. Obviously, if that's simplified, it's the same thing as your original function here. Okay, so is y equal 5 a linear function? Yes, it is. Okay. Now, it asks, for this next one, is xy equals 2 a linear function? Well, let's get y by itself first, and then maybe we can see if it's a linear function. So to do that, I got to divide by x on both sides. Okay. If I'm dividing by x on both sides, I've got y equals 2 over x. Okay. Is there any way to make that look like the function they gave us to begin with? No, there's not, because the x is on the bottom. So is it a linear function? No. Linear function means a line as well. If you wind up graphing that on your TI, most certainly is not a line. So let's look at this one. Is 0 equals 2t minus s plus 1 a linear function? Okay. So we don't have x's and y's, but that actually really doesn't matter too much. Let's solve. The simple one to solve for here is s. Let's solve for s. Okay. So if I solve for s, I'll add a s to this side. I'll add a s to this side. Okay. So that we wind up with a function that looks like s equals 2t plus 1. If you want to write a little fancy here, t, to kind of differentiate between your t's and your pluses, you can do that. So essentially what we have is we have a variable here by itself. An a here, which would be 2, times a variable, plus a constant b, which is 1. So, yes, that's a linear function. If you wound up solving it for t as well, it would still be a linear function. If you solved for t, you should be able to do some pretty simple solving here. But if you solve for t, I believe what you'd wind up with is t equals, let's see, we've got, I believe it'll wind up being an s over 2. And then, let's see, I believe it's a minus 1/2. So that your constant is minus 1/2 for your b. So this would be your b. And your a here would actually be a 1/2. Okay. So you could rewrite that a 1/2 s if you'd like as well. So it's just that 1 over 2. Remember, there's an imaginary 1 next to this s. So that the constant in front of your s is just a 1/2. So yes, this indeed is a linear function. So hopefully that's easy enough for you to see. Now, some of the things we need to talk about are intercepts. So your x-intercept is the point where the graph crosses or touches the x-axis. To find the x-intercept algebraically, we wind up setting y equal to 0, and then we solve. Now your y-intercept is the point where the graph crosses or touches the y-axis. In order to find that y-intercept algebraically, what we wind up doing is setting x equal to 0 and we solve. Okay, so if we want to find an x-intercept, we set y equal to 0. Want to find a y-intercept, we set x equal to 0. Okay, the graph of a linear function can have at most one x-intercept and has one y-intercept. Okay, so if you have a linear function, you're going to have a y-intercept. If you have a linear function, you can have at most one x-intercept. Okay, which means you can have either one x-intercept or no x-intercepts. So, if we look at this, we can show how to find the intercepts on the TI, which is pretty simple. Okay, so if we get out of this, we'll go to y equals. If you want to find simple function, we said in our notes here that our one of these functions up here that was linear. Let's just look at this one here. S equals t plus 1, 2t plus 1. So if I type this in, let my s be my y, let my t be my x, So 2x plus 1, already confirmed that's a linear function. I'm going to do zoom standard. You can see it has one x-intercept and it's got a y-intercept. Okay, so if you want to calculate that x-intercept, you can do second calculate. Okay, and you can do 0 for x-intercept. Okay, so we still have to do the left bound, right bound thing. Alright, and then you guess where it's at, somewhere in here. It finds it for you. So your x-intercept is x equals negative 0.5, y equals 0, which makes sense. We set y equal to 0, we find our x-intercept. Now if you want to find your y-intercept, you don't have to do second calc, left bound, right bound. Just do second calc value. Your y-intercept is where your x equals 0. So your y-intercept here is y equals 1, x equals 0. It's that simple. So you should be able to use your calculator to figure this out. It's really not hard. And that's kind of how it works. So remember, to find your x-intercept, if you pull with the calculator back up, find the x-intercept, we hit second calc, and we wind up doing 0. To find your y-intercept, just use the value function and type in x equals 0. It's pretty straightforward. Alright, make a little note of that right there on your notes if you need to. Alright, so next thing we need to look at is slope. So the slope is obviously a vertical change over your horizontal change, also called rise over run. Slope can be found using any 2 points on the line. If a non-vertical line passes through 2 points, P1, which is x1, y1, and P2, which is x2, y2, its slope is denoted by m. It's found by y2 minus y1 over x2 minus x1. Okay, the slope of a vertical line is undefined. Okay, a vertical line is also not a function because it fails the vertical line test, but that's something we'll get into later on. But we will be finding the slope of functions using this m equals y2 minus y1 over x2 minus x1 a good bit here. So, example says, find the slope of the line between 2 points, -3, 2, and 5, -4. So, does it matter which one's y2 and which one's y1? No, it doesn't. You just need to stay consistent. So if I say this one is x1, that means this one has to be y1, which means this one has to be x2, and this one has to be y2. The biggest thing here, don't get them flipped. You can't have an x1 with a y2 and a y1 with an x2. You can't have that. As long as you keep it straight, it's going to work. If you want to call this one x1 and this one y1 and this one x2 and y2, it's still going to work itself out. So we've got y2 minus y1, so I've got a -4 minus a 2, all that is over x2, which is 5, minus a -3. Okay, now -4 minus 2 is a -6. And 5 minus a -3 is actually an 8. So the slope of the line between 2 points is -6 over 8. In this class we do reduce. And -6 over 8, if you divide both by 2, reduces to a -3 over 4. That would be your answer. Now if we move on along, it says determine whether the slope is positive, -0, or undefined. Obviously, if the slope goes up, it's positive. If the slope goes down, it's negative. If the slope is horizontal, it's 0. If the line is vertical, the slope is undefined. So here, it will be positive. So that's why it says m is greater than 0. Here it's negative. It's going downward. Obviously here it's 0. And here it's undefined, which is exactly what it said right there. And I'll save myself on a little writing. So, if we look at number 3, it says graph y equals 3x plus 2. What's the slope? What's the y-intercept? So, I'm not going to graph this by hand. I'm going to pull it up. 3x plus 2, y equals 3x plus 2. It's a simple graph. There it is. If you wanted some points on it, you could do second table, find some points on it so that you could graph it by hand. Easy peasy. Come back over here. What's the slope? The slope is just the 3. Very simple question. What's the y-intercept? The y-intercept is 2. Now sometimes they want you to write the y-intercept as an ordered pair. If that's the case, you're going to write that y-intercept as 0, 2. Easy enough. On to the next page. Next page says the slope of the graph of the equation y equals mx plus b is m. The y-intercept of the graph is b, so that the graph crosses the y-axis at 0, b. Find the slope and y-intercept in the following examples. This should be extremely straightforward. Obviously, the slope is what's in front of your x. That's your 7. Your y-intercept is this negative 12. Okay, you do have to include that negative. Okay. Now here, it's not as straightforward because the equation isn't solved for y yet. So what I need to do is solve it for y. If I do that, I can leave my negative 3y on this left-hand side. I can subtract 2x and bring it to the right. So minus 2x and then plus that 12. So all I did here is I subtracted this negative 2x off on both sides. Okay. Easy enough. Alright, now I still need to divide by this negative 3 to get rid of it and get my y by itself. So let's do that. Let's divide this by negative 3, which means we divide this whole side here by negative 3 as well. Okay, now when I'm doing that, I'm going to separate the two so that what I get is y equals negative 2 divided by negative 3. The negatives cancel out. I wind up with a 2 over 3 x. And positive 12 divided by negative 3 is actually going to give me, 12 divided by 3 is 4, so it's going to give me a negative 4. So that my slope here is negative 2/3. And my y-intercept here is negative 4. Like I said, sometimes they want you to write it in an ordered pair for the y-intercept. If that's the case, remember your x is 0, your y is negative 4. Okay. Same thing for above. If you wanted to do it for the problem above here, if you wanted to write it as an ordered pair, it would be 0, negative 12. Alright. Now, the constant rate of change of a linear function y equals mx plus b is m. It's the same thing as the slope of the graph. It's just a little different terminology that's sometimes used. Okay, so don't let that trip you up. If it asks for the constant rate of change, it's just asking for the slope. So here in this example, it says, using data and projections from 1990 through 2050, the percent of Hispanics in the U.S. population can be modeled by this function, h of x equals 0.224x plus 9.01, with x equal to the number of years after 1990. What is the constant rate of change of this function? So I know people are really intimidated by word problems, but this one's really straightforward. It's not asking you to do anything except state what the constant rate of change of this function is. So all it really wants you to know is that the constant rate of change of this function is the same thing as the slope of this function, which is 0.224. So the answer to this is 0.224. So don't get caught up in the words. It is important to read through carefully, but a lot of times they might be asking for something really, really simple. Now, page 4. We start looking at profit, revenue, and cost. The whole goal of this class is so that you can actually use math from this class, hopefully in some real life situations. Now, hopefully you know that profit equals revenue minus cost. If you don't, there it is right there on the screen for you. Now, revenue comprises of your cost per unit, or price per unit, times the number of units typically that you sell. And your cost winds up being your variable cost plus your fixed cost. Okay, so if you're going to make something on it, you got to charge something for it, right? So one of the things I do is I sell vegetables at a farmer's market sometimes over the summertime. So if I'm charging $5 for a watermelon, my price per unit is $5 for that watermelon. My number of units sold is how many units of watermelons I sell that Saturday. So if I sell 100 watermelons at $5 a piece, I've made $500. Now my cost here, you've got your variable cost plus your fixed cost. So your variable cost here is something that can change, right? So think about it as, I've got it down here for you. It says variable cost. Think of costs such as light bill, water bill, any input that's subject to change from pay period to pay period. So if I'm running a building, my light bill is not going to be the same each month. Some months I'm going to use more, some months I'm going to use less. In the summertime I'm going to use more because my AC is working, because it's hot outside and it's working to cool the building. In the wintertime, my light bill might be a little less. Water bill can change too. So any cost that can change and that's not constant, it's going to be a variable cost. any constant or cost that's going to stay constant is going to be a fixed cost. So a lot of times these fixed costs are things like rent. Typically your rent doesn't change month to month. Usually you have a pretty set rent. So any input that doesn't change is a fixed cost. Okay. Now something else you need to know: marginal cost, marginal revenue, and marginal profit. All those are the slopes of the respective functions. Okay. So we've got this example here. It says a company produces and sells a smartphone with a revenue given by R of X equals 89.50 X and cost given by C of X equals 54.36 X plus $6,790, where X is the number of smartphones produced and sold. What is the marginal revenue for this smartphone? Okay, marginal revenue is the slope of the revenue function. So the slope of the revenue function here, R of X, is just 89.5. You can write 0.50 if you want to. That's it. That's your answer. Okay, really complicated sounding process or problem, but that's your simple answer. Now, B asks us to find the profit function. Remember, profit, if you really need to go back and review it, it's fine. Revenue minus cost. Okay, revenue minus cost is your profit function. So if we know our revenue function, we know our cost function. If we want to find my profit function, we'll say P of X. Okay. That's just going to be my revenue function, which is 89.5. And you can write 50 if you want to, so it'll match everything. X minus 54.36X. And here's kind of the important part too. If you're going to be subtracting this cost function, it's probably a good idea, so you'll distribute that negative, to put a parentheses around it. Plus 6,790. Okay, now we definitely need to simplify here, and I'll change colors for that so it doesn't all blend together. But if I simplify this function, what I'm going to wind up doing is subtracting 89.5 and 54.36. So you got your TI, you should have one available. You should be able to subtract those, and what you're going to get is 35.14 X. All I'm doing is simplifying that top function, and then it's going to be a minus 6,790. So that is going to wind up being your profit function. So your P of X, your final answer here, is right here in purple, or your one that's underneath here that I'm writing now. Your P of X equals 35.14X minus 6,790. So, oops, I skipped too far ahead. That is your profit function for that one. Let me scroll back up here to where we were at. Now to ask what the marginal profit for the smartphone is. Remember, marginal profit is just the slope of the profit function. Okay, that is 35.14. Pretty simple, pretty easy, pretty straightforward. Here we've got special linear functions. So we've got a constant function. It takes the form y equals b. From that function, y equals 0 times x plus b. It's essentially just when your slope is 0, you're going to have a constant function. Okay, examples: y equals 3, y equals 5, y equals 10,587, y equals 0.0593. Those are examples of constant functions. Y just equals a number. Now if you want to see what this looks like on your calculator, just go to your calculator, clear out your function, type y equals 3 in, graph it, and you'll see it's a horizontal line at y equals 3. Okay, so anytime you get a constant function, you're going to wind up with a horizontal line. Now, the other one you have here is an identity function. So we've got y equals x, or y equals 1x plus 0 if you want to write it in that standard form. Essentially what it is whatever y is, x is. And if you graph this, you'll notice the slope is 1, obviously because there's an imaginary 1 in front of that x. But if you graph this, it's just a diagonal line. Y equals x, graph it, there it is. Alright. So, we've got some examples here. First one says, which of the following functions is linear? Well, if I look at A A says y equals 3x squared plus 2. It's got a squared in it. Linear doesn't have any kind of exponent on the x. So this one's not linear. So this one's not linear. So I'm going to put a no here. This one actually, if we solve for y, I believe it's going to be linear. And it's kind of an important step to solve for y just to make sure. So if I solve for y here, I'm going to subtract this 3x from both sides. If I do that, after that step, I'm going to wind up dividing by 2 to get y by itself. So I get 2y equals, I've got negative 3x, because I like to put the x's first, plus 12. Now, like I said, if I divide by that 2, if you want to change colors, that's fine. Divide by 2 on both sides, and I simplify it. What I get is y equals negative 3x over 2, or negative 3 over 2x, however you want to write it. And 12 divided by 2 is 6, so plus 6. That is most definitely a linear function. So you can put a check, you can put yes, B is a linear function, and you should be good to go on that one. Okay, because it has a slope here, there's no exponent on the x or anything, the x isn't in the denominator or anything crazy, and it's got a constant at the end. Alright, if we look at C kind of matches one of the examples, it gets pretty close to one of the examples we had in the beginning. The x is in the denominator here, with the x in the denominator. I can't make it look anything like this function here, where I've got the x in the numerator, so no, this one's not linear at all. So, we only have one of those that's linear in that example. Number 2 says, find the slope of the line through, and it gives you 2 points. We've got a 4, 6, and a 28, negative 6. So, like I said, it doesn't matter which one's x1, y1, which one's x2, y2, as long as you keep them together. So, to prove that, I'm going to say, okay, instead, I'm going to make this one x1 and this one y1. And I'm going to make this one x2 and this one y2. Okay, to show you that the order really doesn't matter. You just have to keep them with their ones. If I got a 1 on this one, I got to have 1 on this one. If this one's 2, this one also has to be a 2. So that what I'm doing is 6 minus a negative 6 over, and then, like I said, you got to keep it together. So over 4 minus 28. Okay. 6 minus a negative 6 is going to give you a 12. Okay. 4 minus a negative 28 is going to give you a negative 24. If I reduce that, I wind up with a negative 1/2. And that's your answer. So the slope of this line is negative 1/2. Easy enough for number 2. On to page 6. Page 6, we got number 3. It says find the slope of the line of the graph below. It says, or it gives you the graph. So you should be able to look at a graph and find the slope. All you really have to do, you got to start at a point and go to another point. Okay, it's pretty easy to see that this is a point on the graph and this is a point on the graph. Okay, so I'm over here at negative 2, 0. Now you can do the function if you want to do the function, the y2 minus y1 over x2 minus x1. You can do that if you want to, or you can just count. Okay, you can do rise over run. That's essentially what I'm doing. So if you want to write that, the easy way to do it if you're given the graph, instead of doing a whole bunch of math scribbled out on the side, just do rise over run. Okay, I'm at 0 here, okay, on my y-axis. I'm going to rise, this is 2, this is 4. So I'm going to rise 4. Okay, now I've got to run. Let's see if I change my points here, make it red. So I rose 1, 2 to here. Okay, now I need to run to the right. Okay, so to get to this point. So what you got to be careful here is I'm going by 2's here, but on my x-axis here I'm only going by 1's. So I'm going to the right 1, 2. So it's going to be 4 over 2. Need to reduce that. 4 over 2 reduces to 2. Okay, so the slope of the line in the graph below is actually 2. If we move on to number 4, it says if a line is horizontal, then its slope is blank. If a line is vertical, then its slope is blank. So here, if a line is horizontal, its slope is 0. If a line is vertical, its slope is undefined. And I know that this doesn't write as clear as I would like, but I'm working on it. Okay, undefined. Easy enough. Make it fit on the line. Alright, number 5, it gives you an equation and it asks you for the slope and the y-intercept. Okay, the biggest part here, we got to solve for y. Okay, so I'm going to go ahead and move that 3x to the right hand side. Okay, if you need to take a few extra steps to do this, be my guest. Okay, so when I move that 3x to this side, it becomes negative. So 2y equals negative 3x. Got that plus 7. Okay. Now I need to divide by 2 on that y to get it by itself. I'm going to start skipping more steps as the semester goes on. So if you're struggling with this part, you really kind of need to take some practice and work on solving for different variables. So we've got y equals negative 3 over 2x. And plus 7 over 2. Okay, so that your slope here is negative 3 over 2. And your y-intercept, I'm going to write it as an ordered pair. Your y-intercept is 0, 7 over 2. Okay, now for 6, I'll change colors to kind of delineate between the two. For 6, I've got 5y equals 2. Still need to solve for y. So I really just need to divide by 5 here and divide by 5 on the other side as well. Okay, so if I do that, I get y equals 2 over 5. Okay, y equals a constant. Alright, so when y equals a constant, we know that our slope is a 0, and that our y-intercept is just going to be where our line hits our y-axis, which is just going to be at this constant. So it's going to be 0, if I write it in ordered pair form, 0, 2 over 5. Now, if you're freaking out about that a little bit, you can always come over here on your calculator and say, okay, y equals 2/5. Graph it. You'll see, indeed, it's a horizontal line. You see the little blue line there. It does hit at 2/5. That's where it hits your y-axis. And you could check that if you'd like to. You could do second calc. Value 0. And it's going to give you the decimal for it, which is 0.4, but that's the same thing as 2/5. Okay. Number 7. X equals 6. What's the slope here? Now, whenever x equals a number, that's when you're going to have a vertical line. So you're going to have a vertical line at x equals 6 here. If you have a vertical line, then your slope here is going to be undefined. Slope of a vertical line is undefined, and that's what x equals 6 is. So your slope is undefined. And your y-intercept here. When you have an undefined slope, you're not always not going to have a y-intercept, because if the line is x equals 0, you'll have all kinds of y-intercepts, an infinite number of y-intercepts. But here, if I've got a line at x equals 6, so I'll kind of rough sketch it out for you. You've got your xy axis here. Okay, so x equals 6, so 1, 2, 3, 4, 5, 6. So you got a line through that x equals 6. It's a vertical line. Oops. Sorry. It's supposed to be a straight vertical line. Through that 6. Remember, this is your x-axis here. This is your y. You got a vertical line. The slope's undefined. Y-intercept, it doesn't have one. So you can just write none, because it never hits that y-axis. It's actually parallel to the y-axis, so it never actually goes over there and hits it. Now if I move on to page 7, down here, it says for number 8, y equals 50,000 minus 100x. and it gives you this 0 to 500 range to look at. So it says find the slope and the y-intercept. Okay, your slope here is going to be whatever number's in front of your x, and you do have to include that negative. So we're looking at negative 100. Your y-intercept here is going to be your b, so your constant. So if you write it as an ordered pair, it's going to be 0, comma 50,000. Okay. Now B says determine whether the graph is rising or falling. If I've got a negative slope, it's falling. If you're not convinced, you can come over here, say y equals, let's clear it out, 50,000, and then minus 100x. Okay. If you do a standard zoom on this, you're probably not going to see much. You don't see anything. If you do a zoom fit, this is kind of what you see. You can see the graph falls. Okay, so you can answer your question with a zoom fit here. So it is falling. Alright, it says graph the function on the window given. So let's look at this window, 0 to 500. So if my x goes from 0 to 500, okay, and I graph it, okay, that doesn't really show me very much. If I do zoom, let's do zoom fit after that. What you see here is my window is preserved 0 to 500, but it adjusts that Y scale where you can actually kind of see what's going on. So I've got my from 0 to 500. I did a zoom fit, it adjusted my Y where I can really see my line. I can definitely tell it falls here, right? And I get actually a really good view of the graph. So we've graphed the function on the window given, and we were able to do that. I just want you to be able to work with your calculator some. Alright, number 9 says if a linear function has the points 2, 1, and 6, 3 on its graph, what is the rate of change? Okay, remember the rate of change is the same thing as the slope. Okay, that's really all we're looking for here. Okay, so we've got these points 2, 1, and 6, 3. Okay, doesn't matter which one's x1, which one's x2, but you remember, you just got to stay consistent. So if this one's x1, this one's y1, that means this one has to be x2, and that other one has to be y2. Okay, so that what you wind up doing here, y is 3, or y2 is 3, y1 is 1, so 3 minus 1 over, and you just got to stay consistent. So now I've got to do 6 minus 2. Okay, I'm just throwing that in parentheses. Okay, 3 minus 1 is 2, 6 minus 2 is 4, 2 over 4, simply a half. Okay, so your slope here is a half, your rate of change is a half. Okay, that's the answer to your question. 1/2. Now, this asks, what's the slope of the identity function? You got to remember with this question that the identity function is y equals x. Okay, if y equals x, the slope is 1. That's your answer. Easy peasy. Alright, number 11. The balance of the federal direct student loans S of T in billions of dollars for selected years from 2011 and projected 2023 can be modeled by, we've seen this function before, with T equal to the number of years after 2011 and S equal to the balance in billions of dollars. Okay, so what is the slope of the graph of this function? Well, the slope is just whatever's in front of this T here. So the slope here is 130.7. That's pretty easy. Okay, like I said, really complicated sounding word problem, really simple, easy answer. Alright, I believe 12 is the last one we got. So 12 says the percent P of high school seniors who ever used marijuana can be related to X, the number of years after 2000, by the equation 25P plus 21X equals 1,215. Let's find the x-intercept of the graph of this function. So the x-intercept is where it hits the x-axis. To find the x-intercept, we're going to set p equal to 0. So if I set p equal to 0, I get 25 times 0, which is obviously 0, but I'll write it on out so we can do this plug-in, plus 21x, and that equals 1,215. Now, like I said, that 25 is just going to cancel out with that 0. When that happens, all I really got to do is divide by 21 on both sides. That'll give me my x, and that'll give me my x value. Okay, so 1,215, you can take it on your calculator and do it. 1,215 divided by 21 should give you a decimal. Okay, it's not always going to be a pretty whole number. So if you want to see it, if I clear this out, I'm looking at 1,215 divided by 21. It gives you 57.87 or 857.14286 approximately. I'm going to round it 2 decimal places. I'm going to say 57.86. Typically, we'll tell you how many decimal places to round with, especially with the MyMathLab setup. So, x equals 57.86. That's the x-intercept of your graph. If you wanted to write it in ordered pair, it would obviously be 57.86 comma 0. B says find and interpret the p-intercept of the graph of this function. Okay, so to find the p-intercept, I got to set x equal to 0, so that what we get here, we get 25 times p, so 25p, plus, if we're setting x equal to 0, we just got 21 times 0, which is going to wind up canceling itself out, equals 1,215. Okay, like I said, that 21 and that 0 kind of cancel themselves out, so that all we really have to do is divide by 25 on both sides. So 1,215 divided by 25 lends itself to p being equal to, let's put it on the calculator and solve it. $48.6. Alright, so here at year 0, 48.6% of high school seniors had used marijuana. So what you're looking at here is essentially in year 2000, which is year 0, 48.6% of high school seniors had ever used marijuana. That's how you would interpret this, and you can write that down if you'd like to, because that's the interpretation you're going to be able to need to know and use. Now, it also says to graph the function on your calculator. If we do that, our p is obviously going to be our y. We would need to solve for our p if we wanted to do that, so that what we wound up with, I'm going to go ahead and pull that x to the right hand side, and then we'll solve a little more. So we'll get 25p equals negative 21x, and then plus 1,215. Okay, obviously got to divide by that 25. So if I divide by 25 on both sides, you could simplify as much as you wanted to, but I'm going to type it in direct, so that my final function I'm going to type in my calculator is p equals negative 21 over 25x plus 1,215 divided by 25 is 48.6. I'm just going to use the 48.6 because it came out nice and neat. If you didn't see what I did there, 1,215 divided by 25. We already found that. It's 48.6. So in my calculator, what I'm going to type in is y equals negative 21 divided by 25x. And then if I pull it back up, it's going to be plus 48.6. Okay. Now, if I graph that, obviously it didn't show up well in the zoom that we've had. If I go to standard, it doesn't show up well there either. So if I go zoom fit, maybe I'll get a good fit on it. That's a pretty decent fit. Let's look at and adjust our window. We don't really care about anything before 2000 at this point. So if I adjust that, I can see, okay, from year 0, which is 2000, we went 10 years out in the future, which is 2010. It looks like it's really, really decreasing. So if we look and check everything on here, make sure we made no mistakes, with the function itself, what it's looking like is that the amount of people using marijuana, according to this function, is supposed to be decreasing as time goes on from 2000. Something interesting to see is this function is actually probably going to predict it hitting 0. So if I look at, let's just look at the table. So how many years out do we have to go, okay, before we actually hit 0? The graph makes it look like it hits 0 pretty quick, right? But something that we might need to do is we might need to go zoom fit again. Remember, we've got our x's stated. So what I'm looking at here, it still looks like it's hitting almost here at year 10, right? Which makes no sense. Okay, but if you look at your window, that's not actually what's happening. Your Y here is going from 40.2 to 48.6. So the bottom bar you're seeing here, even though it's got ticks on it, isn't actually 0. So you gotta be a little careful with that. So if you truly wanted to see 0 on your Y min to see exactly where you were at, you'd have to graph it like that. Then you notice you are way above that 0. So it doesn't suddenly drop off, but it does certainly decrease. Okay, so evidently marijuana usage is going down after 2000 according to this function. Alright, so that's kind of the interpretation that you should be able to see and kind of work through some of these problems. It's interesting to look at the graphs and the numbers and see how they work, be able to manipulate them and everything else. We'll expand a little more in chapter 1.4. Make sure you do your online homework. If you have any questions, please email me. Other than that, like I said, tune in for 1.4 if you're ready for it.